Hello, Poppets. Okay, we're going to continue talking about the dorsal column medial lemniscus system. And to reinforce the concept, this pathway is responsible for 4 different things: soft touch, proprioception, or my awareness of where my body is in space, vibration sensation, and 2-point discrimination, being able to feel 2 simultaneous touches at the same time. Now, in the previous video, we talked about this pathway looking as if I was feeling sensation from the base of the left big toe. But this pathway carries information through the upper body as well. It's basically the same principle in that it's still a 3-order neuron. It still decussates or crosses over to the opposite side of the body, but the tract, the fasciculus that carries information from your upper body, your arms and whatnot, is a little bit different. This is called the fasciculus cuneatus. Okay, the fasciculus cuneatus. And if you look at this picture here, if you imagine that this is any transection, so if I took your body and I cut it in half and then I flipped it up for you to take a look at, this is any transection of your spinal cord. On both the right and the left side, you've got the dorsal column here, which is carrying sensory information from the dorsal column medial lemniscus. But if you consider this like one highway, there are 2 different lanes. And the lane that carries information for the legs, which we learned in the last video is called the fasciculus gracilis, is slightly more medial. And the lane that would carry information for the upper body or the arms, the fasciculus cuneatus, is slightly more lateral. But they're both traveling alongside each other, going up ultimately to end in the primary somatosensory cortex. And remember, the somatosensory cortex is laid out. If you remember, we talked about something called the homunculus, or the little man. And if you imagine the little man kind of laying down here, and you've got the eyes, the lips, you've got a hand, you've got the legs, and then you've got the foot, okay? It basically means that some of the information is going to be headed up towards the hand, and some of the information might be headed more down towards the foot aspect. That's all that it is. So it's 2 different lanes of the same pathway, the dorsal column, but for the upper body, you need to remember the fasciculus cuneatus. Otherwise, there's no real difference. So let's just take a look at how this would actually work. So let's imagine that I was feeling sensation, and let's imagine that I was feeling sensation coming into my thumb, okay? Right here in the thumb, on my left side of my body, okay? Well, we know, because this is a sensory pathway, we must start with a receptor which is located in the skin of the thumb, picking up that sensory experience. And what that does is that triggers action potential, which is passed like a football along the axon of the 1st order neuron. And that 1st order neuron is going to run all the way from my thumb, through my hand, down my arm, and then it's going to enter into the dorsal root. And this is going to be the dorsal root because this is my C6 dermatome of C6. And it is going to ascend upwards via the dorsal column on the pathway of the fasciculus cuneatus. Okay? So if this was C6, this could be, for instance, C2. Okay? It goes all the way up the spinal column, and this is the dorsal column aspect, continuing up until it hits the medulla. And that is just like the previous experience we talked about with the leg. The only difference is that this time it's in the fasciculus cuneatus, not the fasciculus gracilis. Now, as we talked about before, the 1st order neuron traveling from thumb all the way up spine into medulla, that's going to end there. And what we're going to have is a synapse, like they're giving each other a high five, Or you could consider this neuronal transmission, communication between two neurons. That happens right here. So here is my second order neuron cell body, which is now picking up the action potential. The action potential is going to be passed like a football along the axon, and the axon decussates, or it crosses over to the right-hand side, because remember, the opposite side of the brain will control motor aspects or receive sensory information from the opposite side of the body. So here's my second order neuron, which is decussating in the medulla, traveling up through medulla, pons, midbrain, and it's going to exactly the same point. It's going to the ventro-posterior lateral nucleus within the thalamus, and it ends there. Again, we've got our connection with our third order neuron, okay? They synapse here at the VPL like they're giving a high five, and the action potential will be carried like a football along the axon of the third order neuron until it hits that specific point of the homunculus within S1 that particular cell body would rest, okay? And that's going to be within the parietal lobe. So again, to recap, remember, a sensory system like the dorsal column, medial lemniscus, must start in the skin, and it must start with a receptor. So I have a receptor in my thumb, which picks up pressure sensations, say, triggering an action potential, which is passed like a football along the axon of that first order neuron down the arm, entering in through the dorsal root at the corresponding dermatomal level. This is my C6. And then ascending up via fasciculus cuneatus of the dorsal column all the way up the spine until it hits the medulla. At the medulla, the first order and the second order neurons synapse or communicate, and that action potential is going to be passed like a football along the axon of the second order neuron, which decussates or crosses over and then continues on the contralateral side all the way up through medulla, pons, midbrain to end in the VPL of the thalamus on the right side of the body. The second order neuron synapses or communicates with the third order neuron here at the VPL, and that action potential is passed like a football along the axon of the third order neuron, which terminates or ends in the appropriate aspect of the homunculus of the primary somatosensory cortex within the parietal lobe.